All right, we're going to talk about some exponent rules. You got this note. We're going to do this near the end. So flip it open, turn it around. Let's look at this. So how do exponents work? This part of your notes, your left side, was going to be review from elementary school or junior high school. What is an exponent? We remember from a long time ago that they told us it was repeated multiplication. Repeated multiplication, which means 2 to the third power, I'm going to go 2 times 2 times 2. I got 3 of these. That's my rule there. W to the fourth power means W, 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 and W. So that's basically what an exponent is. It's a shorthand way of telling me what to do with this base. Here's my base. And this is my power, what I'm going to do with my base. So how do we add exponents? Or how do we add bases with exponents? Well, the rule is they must be like. For example, x to the fourth plus 5x to the fourth equals 6x to the fourth. These are like terms, meaning it's the same base to the same power. Then you can add the coefficients. So 1 plus 5 is 6. If you try doing something like this, g to the third plus g to the fourth equals, I don't know, doesn't work. Let's try another color. So let's try one other one. 5xy squared plus 7xy squared. That'll be 12xy squared. Must be like add the coefficients. That's what you're doing. You're adding the coefficients. So what about multiplying? When you're multiplying, let's go over the rules again. 7 to the third power times 7 to the fourth power equals 7 times 7 times 7, right? That's this repeated multiplication. I got 3 sevens times 4 sevens. Well, don't I have a total now of 1, 2, 3, 4, 5, 6, 7 sevens? So what we're going to do, as long as you're dealing with the same base, you're going to add the exponents. Add the exponents. And I'll try another one. I'll just do x squared y cubed times x y to the 8th equals, well, in this situation, here are my bases, my x's. I have 2 and 1. I'm going to add the exponents. 2x's, 1x, x cubed. I got 3 y's and 8 y's, 11 y's total. If I wrote it all out, it would look like this. X, 1, 2, 3. X, 1, 2, 3, 4, 5, 6, 7, 8. 3 of them, and then one, two, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what happens when we divide? Well, if we add the exponents for multiplying, here's something you may remember from a long time ago. If I write 3x to the 5th, this would be 3x, x, 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 over x, 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 x. Remember to cross out the common factors in the numerator and denominator. This is 4th grade equals 3x. You may not remember this from 4th grade, but this is the skill that was taught. Okay, what did I basically do here? I took these 5x's and these 4x's and wound up with 1. There were more on top than on bottom. How many more? 1 more. So we're going to subtract the exponents. Now for the next part. This is where you may still have this in 6th grade, or the first time you see it is in high school. Basically, it's power of a power. So if I have 2 squared to the 3rd power, this means 2 squared times 2 squared times 2 squared. I got 3 of these. 1, 2, 3. Well, if I'm multiplying the same base, I'm adding the exponents. 2 to the 6th power. Let's try another one, just to make sure it's good. 5p to the 4th squared. 5p4, 5p4. Well, that's like saying 5 squared, p, 8. Yeah, 4 and 4 makes 8. I could even say 25p to the 8th because 5 squared is 25. All right, this is where it gets very interesting. What do you do when you have a negative exponent? I'm going to do a little logic here with you. Let's say I've got the number 3. 3 to the 1st power equals 1 times 3. That equals 3. 3 to the 2nd power equals 1 times 3 times 3, right? I got 2 3's. Well, 3 times 3 is 9. 3 to the 3rd power. 1 times 3 times 3 times 3, 27. I can keep going. It goes up to 81, etc. But you're wondering, well, where's the negatives? Well, let's go there. We need this to help us understand, maybe. As the power gets smaller by 1, let's go to 0 first. What's happening to my answer? Well, I got 1 less 3, so it's kind of like dividing by 3 when I'm going down. So if I divide by 3, my answer is going to be 1. Oh, so this 3 is gone. I have no 3's, but I still have the 1. No 3's, I have my 1. Now we're going to go negative. Every time I go down 1, I divide by 3, right? Well, what's 1 divided by 3? I guess I could say my 1 divided by 3. 3 to the negative 2 power. (1/9). And 3 to the negative 3 power equals 1 divided by 3, divided by 3, divided by 3 is 1 over 27. So are we saying that if I have a third power and a negative 3 power, it's the reciprocal? 27 over 1, 1 over 27. So a negative exponent take the reciprocal of the base. So I'm going to give you one more example just to try out. Or g to the negative 4th power equals 1 over g to the positive 4th power. Just like this would be 1 over 3 to the positive 3 power. And one last one. 2 over x negative 3 power becomes x over 2 to the positive 3 power. This one goes to the bottom, this one goes to the top. Sign switches. Last one, rational exponents. A rational means ratio, fraction. What happens when I have something like 16 to the 1/2 power? Well, I have no idea. All I know is it's going to be between the base and 1. So it's going to be between 16 and 1. Because it's between 1, my power is between 1 and 0, it's going to be somewhere in the middle. But I do know this. If I take a power of a power, I'm multiplying them. So what number can I multiply by to turn this into a 1? 2. 1/2 of 2 is 1. Okay, so 16 to the 1/2 power to the 2 power is back to 16. What could this be? So what number squared is 16? Oh, well, 4. 4 times 4 is 16. What? So 16 to the 1/2 power equals 4. What do you do to the number 16 to get a 4? Isn't the square root of 16 the same as 4? The half power of 16 is 4. So these two are the same. Here we go. That's what we got at the bottom. 16 to the 1/2 equals square root of 16. Go to the front page. We'll talk more about this in a minute. Go to the front page. We're just going to quickly write down the rules. When you're multiplying bases, you add the exponents. So x times a plus b. Dividing, you're subtracting the exponents. Power of a power, you're multiplying the exponents. Power of a product, you're going to distribute. Power of a quotient, you're going to distribute. Negative power tells you to do the reciprocal. And zero power means, so long as this is not a 0 to the 0 power, is 1. That's from right here. 3, where are we at? You seeing it? 3 to the 0 power is 1. Anything to the 0 power would be 1. Now here's your last step. You got this note page. We just talked about fractional or rational exponents. This number in the bottom is your root. Did you know that there could be roots other than a square root? There could be cubed roots, fourth roots. This is an 11th root. My power is my numerator. My root is my denominator. We're going to do a little bit of practice with this in a minute. So as soon as you write this down, let's do our assignment.